This video is intended to go over the in-class work for 222. And what I would encourage you to do is to get the PDF and to try this, and then you can kind of check through and hear kind of the discussion points as I go through this and kind of create an answer key here for you. So what is Cecil's tightrope? What if Cecil's tightrope was a number line like the one shown below? Okay, now remember Cecil's the person who's going to go back and forth on a tightrope and moving this way or this way in each direction. Now what we have is we're introducing negatives, right? So on the same number line, start at 3 and represent 3 plus 2. So here we are at 3, right? And 3 plus 2 is, so I could start at 3. This would be my 3 plus 2. And where did I end up? We ended up at 5 on this one. But if I go 3 plus a negative 2, so I'm starting here at 3 plus negative 2, I'm going to go here, start at that 3 again, but the plus negative 2 is going to take me back, right? So that's a plus negative 2. Also a subtraction of negative 2 where I end up here at 1. How are these two problems similar? How are they different? Try to answer that as best as you can on your own, but one way we can look at it is they both use addition. They're both using the same numbers. However, one's with the numbers as far as, the start point of 3. However, one's a 2 and one's a negative 2, right? And with a negative 2, that's like we have subtraction. Describe how the two problems 8 plus negative 5 and 8 plus 5 would be related if you represented them on a number line. So if you represented them on a number line, how would they be related? Well, they would have to have the same start point, wouldn't they? However, and they're moving 5 units away in both directions, right? Moving 5 units. The difference is, right, one would have to go in one direction and one would be going in the other direction. How can you represent negative 2 plus 5 on the number line below? Well, what does that mean? First off, that negative 2 says we're going to start at negative 2. What's a plus 5? Well, we're going to go up 1, 2, 3, 4, 5, right? There's my plus 5 ending up at 3. For Cecil's new act, his tightrope is 5 feet long, right? Explain why 5 plus 2 plus negative 2 is equivalent to telling Cecil to move 5 feet to the right. How is it equivalent? Well, the equivalent is that when we move plus 2 and then we have a plus negative 2, those really are a plus 2 this way, but then we're going back with a plus negative 2 in this direction, which means we have a net, or it comes out to be no change with a plus 2, negative 2, right? So what we notice is this has no change. Okay. All right. Will 5 plus 2 plus negative 2 plus 3 plus negative 3 get Cecil to point B? Well, what happens to the 2 plus 2? We have no change. 2 plus negative 2, sorry. What happens with the 3 plus negative 3? Ooh, we also have no change. So if we have no change from 3 plus negative 3 and 2 plus negative 2, where did we start? That's where we're going to end. Again, I'm not writing necessarily all of these things down. Those are for you to kind of do as you're kind of hearing some of this. Find the lengths of the tightrope if each expression for rope lengths below starts Cecil at point A and has him end at point B. Assume the numbers represented lengths in feet. Positive numbers make Cecil move to the right. Negative numbers make Cecil move to the left, right? So you could draw all of this out, right? But we can think about if he's starting at 9 and we're going to move 2 to the right, we have an 11, right? And then while he's at 11, we're going to move 5 more to the right, so that's 16. When I have a 16 plus a negative 1, that plus negative 1 is going to move me 1 to the left, and I'm going to end up at 15. 4 plus 6 plus 3 plus negative 4. Starting at 4, going to move 6 to the right, that's 10. Then I'm going to move 3 more to the right. The plus -4 says I'm going 4 to the left. 8 plus -3 plus 2, right? So 8, I'll represent it a different way, plus 8 minus 3 plus 2. Right? Where am I going to go? Well, plus 8 minus 3, plus a -3 is positive 5. 5 plus 2 is 7. 12.25 plus 7.5 plus -1.75. All right, now we start utilizing just regular, our kind of addition, subtraction methods, right? 12.25 plus 7.5. So I'm starting at 12 1/4. I'm going to move 7 1/2 to the right, right? So 1/4 plus 1/2 is going to be not 0.75. Sorry, that's going to be 0.75, right? The 12 and the 7 makes it 19. 1975 plus a -1.75, right? Now, that's like subtracting 1.75. We can do that on the side if we need to. And we notice the 75.75s or 75 hundredths disappear, so we end up at 18. Over here, we have 6.1, and we're going to move 3.05 to the left, right? So that's like taking 6.1 and us subtracting 3.05. Ooh, I'll slip a 0 in there right away. Now, what I'm looking at is I notice on the 10 hundredths, take away 5 hundredths is 5 hundredths. And then 6 take away 3 is 3. So I have 3.05 plus a -2.05, right? Again, it'd be like the subtraction. We can do that on the side. Our answer will turn out to be 1. Okay. Now we got a little in fractions. We're going to start at 8 1/2, and we are going to move 1 1/4 to the left, right? So we could also subtract 8 1/2, take away that 1 1/4, right? Now, I could say, what's 1/2 minus 1/4? Or I could also take and make the 1/2 2/4, right? Make them into quarters, so we're talking the same language. So we have 2/4 minus 1/4, that's 1/4, and then 8 minus 1 is 7. All right. Sally lives in North Dakota where the winter temperatures are often below 0. One day, the thermometer reads 10 degrees below 0, but it rapidly rose 15 degrees in 1 hour as a warm front moved in. Then it dropped 15 degrees at nightfall. What's the resulting temperature? So we're starting at 10 degrees below 0, means that I'm starting at a -10. I put parentheses just to help me focus on that it's a -10. I don't have to have them there. But it rapidly rose 15 degrees, right? So that's a movement to the right. So that is an increase of 15 degrees. Then what happened? It drops 15 degrees as night fell. So that's a movement to the left, and there's my -15. What do we know? That's a change of 0, right? 15 and a -15, they cancel, right? Kind of just cancel each other's movement. So my answer would be back at -10 or 10 below 0, right? Again, I don't need parentheses on that. Sorry. There we go. Gina was working on number 5 when she had a new idea. Look, she boasted, I can use these ideas to add large numbers quickly without showing any work. She wrote down each of the following problems and found each answer quickly. Explain how she could have done this. So she did 583 and 6/10 plus 212 and 72 hundredths plus a -583 and 6/10. Well, what do we recognize? These are a net of 0, right? They cancel each other out. So my answer is 212.72. Explain what we just kind of highlighted in purple down below. Now I have 313 and 6/11 plus -300. Well, what do I recognize? In here, what is that? That is 300 plus 13 and 6/11. And I still have the plus -300 at the end. Why would I do that? Well, because what do I know about these two? Answer is 13 and 6/11. Explain that please down below. Down here, I could break that 314 up, right? I could break that up to be 200 plus 114. Then I still have this negative 114. What do I know? Those two cancel, don't they? Please explain that down below. Write an addition problem to represent each of the number lines below. Where do we start? Start at 4 plus what? Negative 2? Nope, not negative 2. Negative 2 is where I end up. The answer is negative 6, right? That's an addition problem for that one. Where do I start on the left or the one on the right? Well, I start at negative 4. Where do I move? Moving to the right, so I'll have a positive number. I don't say plus 3. That's where I'm ending up. I need negative 4 all the way up to 3. So 1, 2, right? 1, 2, 3, 4, 5, 6, 7, plus 7. Okay? In reference to the tightrope, the sign of the number added told you which direction to move, while the sign of the number told you how far to move. The number that you moved is one way to describe the absolute value of a number. The absolute value is the distance a number is from 0 on a number line in either direction. The symbol, that symbol right there, is used to indicate the absolute value of any number x. Evaluate each absolute value below, value expression below. So we start at negative 20 and then we add 5. So all I'm focusing on is what's happening in here. I'm starting at negative 20. I'm going to add 5, right? So that's going to put me at a negative 15. The absolute values still kind of sit on the outside. So the absolute value is now asking you, how far is negative 15 from 0? It's 15 units away. In B, I'm starting at 0, and I'm going to add a negative 3. So I'm starting at the 0 spot on the number line. I'm going to move negative 3 to the left, right? Don't do anything with my absolute values. That gives me negative 3. Absolute value now says, hey, how far is negative 3 from 0? Now, in this case, there's some little bit of trickiness with this negative on the outside. So what I'm going to do is I'm going to put my attention to what's on the inside. I'm going to start at 2, going to add a negative 3. So inside, that's going to put me at a negative 1. What's the absolute value of negative 1? Well, how far is negative 1 from 0? Well, that's 1. So this one right here, or that negative, I mean, needs to carry over because everything that's inside, that's in the blue part, right, the absolute value in the negative 1, the absolute value of negative 1 is 1. But that negative out front carries over. Answer is negative 1. So be cautious about saying every time you see a absolute value that the answer is always positive. The answer isn't always positive. It just depends on where our negative signs are. Lastly, what happens when Cecil goes forward 5 feet and then goes back 5 feet? Where does he end up? Right, we just talked about how positive 5 and a back 5, right? So Chad decided to record Cecil's movement with the diagram at right. Explain what you think his drawing means. Well, it looks like he has 1, 2, 3, 4. Oh, I moved 4 times plus my initial one, right? So 1, 2, 3, 4, 5. There's 5 movements to the right with those positives, and he has 5 that are in that negative direction, right? And there we go, right? So that kind of helps to represent his movements, doesn't it? So using that same strategy, Chad recorded a different set of instructions for Cecil with the diagram shown. What could this diagram represent? How long is the tightrope if these moves end at point B? Struggling there for a second. So it appears as if he uses 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's a, plus 9. What do I have down here? 1, 2, 3. I have a plus negative 3. So that is a 9 plus negative 3. Where does he end up? Well, from our previous work, we could probably figure out that he ends up at 6. But let's look at the diagram for a second and see where that is. if we notice something, these cancel out, right? For every plus there, there's a backwards. For every plus here, there's another backwards or movement to the left. For every movement to the right, there's another movement to the left. What does that leave us with? 1, 2, well, I can't put negatives in there, sorry. I'm just trying to underline because I know you can't see me. See this? 1, 2, 3, 4, 5, 6. That's no coincidence and probably isn't a surprise to you, but that's something for us to think about, and I wanted it to be a concept that you guys are left with because we're going to use that moving forward. If you have any other questions, please let me know.